So yeah, my name's Sean. I am an enterprise Node.js developer since I work for a publicly traded company. So I wanted to talk to you a little bit about kind of how Groupon's platform stopped working. We were kind of a notable Ruby on Rails shop for a while, especially kind of coming out of Chicago around 2008. How we rewrote our Ruby on Rails app, and then kind of what was awesome about it and what kind of was terrible as we went through the transition. So we'll start with the problems. We had this huge monolithic Ruby on Rails app. It worked really well for us for a long time. It let us grow our business to become, at one point, the fastest growing company of all time. And we had a pretty small engineering team that allowed us to do all this stuff. And at the time that we went through all this, like, our website was really like 3 pages, like a deal, you enter your credit card number, and then you can print out the voucher. So after we kind of had the model that worked well, if you've worked in e-commerce or anything like that, you know that as soon as you launch a product in the US, competitors all over the world are going to rip you off and try to like eat your market share worldwide. So that's what happened. We had these three big companies that went off and kind of launched their own daily deal sites. And we realized that we didn't have the operational knowledge to kind of operate, like to launch into those markets. So rather than try to like compete head to head, we just acquired those companies. And for a while, they operated as independent business units, and they would just, they kind of took the Groupon look and feel, put it on their website, but it was a completely separate platform. And like for all intents and purposes, for years, they were completely different businesses. So this is kind of what our application stack looked like. Nothing super surprising here, but really we had 2 monoliths. And if you kind of extrapolate it to those other ones, we had probably up to 5 monoliths going at once. You see in the US, we're using Nginx, Ruby on Rails, and in Europe and most of Asia, they were using Apache and Java, different database backends, stuff like that. So like we couldn't have had more divergent technology choices than they kind of, this natural kind of acquisition brought into our plate. And then something else kind of changed about our business. 2008 was right around the time where mobile e-commerce was taking off. So as of today, like almost half of Groupon's business happens on mobile. And in order to launch a mobile app worldwide, what we did was we built out REST API on each one of those platforms that followed the same contract. So if you wanted to get a deal, you would hit v2 deals, foo deal.json, and you'd get a really similar structure back. So we would have kind of 2 facets of our monolith, the web layer and then the API layer. But that really multiplied out to 2 facets by each one of our monoliths. So this was beginning to kind of be hard to manage. If you wanted to roll out a feature, we would be stuck in this mire of process that we'd have to go through. We would have to build them out for web and mobile. They would be kind of separate contracts. Usually, the way product engineering works is like they get built on web really quick. If we validate it, then we'll integrate it into our native iOS and Android apps. But that was, the data model would get weird. We'd build it out for web, and then it wouldn't quite work through the REST API. And we also kind of got stuck as we wanted to change our business a little bit. We wanted to roll out these features worldwide, but we would have to build them at least 4 different times, if not more, if we wanted to really support most of our audience. And the other difficult part was we were kind of stuck on 2008 web look and feel. I don't think Groupon, when it launched, was an attractive website to begin with, and it didn't age well at all. But we were kind of stuck with this old Groupon with the rhombus look that your mom probably didn't care about, but all of our designers and stuff were getting really sick of it. So we tried to change the look and feel of the website in our old monolith, and that didn't work too well either. We found that just the way that our site was structured, we had to, our monolith was so slow and so hard to manage that we would actually throw most of our website on the CDN. So if you went to a deal page, that was actually served directly through Akamai. It didn't hit our application stack at all. So if we wanted to do like a site redesign, we'd have to do A/B testing at the CDN level, which fragmented our cache and made our website significantly slower for the time that we'd be doing the transition. So we're like, oh, that's not going to work. So we it handcuffed us from even making our website look modern. And then the worst part is that when you have a monolith like that, if you have a back-end issue, the entire website goes down, and there's not much you can really do about it. So, for days that we wanted to run huge deals, the site would go down. Like, people wanted to come to Groupon and wanted to give us their money, and we couldn't take it. So it's a huge problem. So we kind of formulated this plan, which was to start kind of tearing this monolith apart at the front-end layer. Like, we had these nice REST APIs that we built for mobile to let mobile roll out this one application code base and use it worldwide, talking to the different backends. And the backend services are just a little bit more complicated, especially if you're dealing with laws about how you store user data and different currency conversion stuff. It's best to just kind of leave that to the backend services and get to that later. So we had these design goals of not only how we wanted our application stack to look like, but how we wanted to work. We started off as this company that just kind of did one daily deal, but we migrated into these different products. So we'd have a goods business and travel business, and there are a couple of people here today that it's from our acquisition that allows you to book high-end restaurants and make a reservation right on the website. And all those teams kind of had a different idea of what their products needed to be, and we wanted to let them kind of flesh out the entire product without needing to be blocked on other teams. And also, you didn't want some other team to come in and overwrite the work that you had done because you weren't coordinating. We went from one office to having I think we have engineers in 10 different offices around the world, all running different products. So having a little bit of self-determination really helps. And our old monolith was really hard to internationalize and localize. If you've ever tried to internationalize an app that has hard-coded English strings, you realize that ship has kind of already sailed. It's very hard to go back and rip all that stuff out. And we just wanted to make sure that the applications were only kind of covering the area that was relevant to them. Don't try to cram too many features into one. So this is a way of visualizing how our monolith looked. We had all these different segments in one huge application, and we wanted to just break them apart like this. So everything would just be kind of loosely coupled together. So we started with this bakeoff. All of these technologies are used at Groupon right now. And each one of the champions of the technology would come to an architecture meeting and be like, we're going to use Play, and we're going to use Vertex, and all that stuff. And this isn't a really good way to evaluate a technology decision. Every technology has upsides and downsides. It's really about who your target audience is and what kind of development lifecycle you're optimizing for. And we picked Node because it kind of hit the sweet spot for the kind of developer that we were targeting. We weren't trying to enable systems engineers to do this work. We were trying to enable front-end engineers, people who wrote HTML, CSS, and JavaScript all day long. Node.js allows them to use those kind of familiar paradigms on the server. And it already had, NPM was great because out of the kind of from the beginning, a lot of popular client-side libraries were immediately available to use on the server. So if you wanted to use underscore or something like that, it was just there for you. And it was fast enough. You can go through and read those performance benchmarking tests of how many hello worlds you can crush through your web server. That's kind of irrelevant to what most websites actually need. But it was fast enough. And I can't underscore this enough. Just letting your front-end developers write JavaScript is a huge organizational benefit. You hire these people because they're good at 3 things, and then you ask them to learn a 4th thing because that's the technology stack that you had in your company. Let them be good JavaScript developers. And in fact, I found that a lot of the developers who came in doing front-end work got better at JavaScript because they are now using it all the time. It's kind of like muscle memory. The more you work at it, the better you get. So at a high level, this is what our stack is right now. We have Apps written in CoffeeScript. We've been using CoffeeScript at Groupon for a really long time. For a while, we actually had a core committer to CoffeeScript working at the company. We used kind of just a really lightweight Express skeleton that we've kind of amputated, so we don't let teams do a lot with it. They can only respond to web routes. They can only respond with JSON and HTML or plain text. We built our custom view engine, so like, with Express you can kind of plug and play whatever you want. We decided that we're going to force you to use Mustache, and we're going to force you to take all the logic out of your templates. Like, this is like the #1 complaint that I get, is that why can't we use handlebars or something more complicated? Just because I think, a clear separation of, coming from Rails, this might have been a reaction to like seeing people do active record statements in a query, in a template is like the worst thing that you could ever do, especially when you're trying to figure out what's going wrong with an application. So this level of separation was pretty valuable. And we built out this custom asset pipeline that is always a terrible idea. You should never do that. I caught a little bit of the kind of like talk about how everybody uses different tools, and for some reason I decided that we needed to make our own. But we're actually currently gutting this and moving to Gulp pretty soon. And then we created these boundaries about what the applications could be responsible for and how they could interact with the rest of our services. So they can only talk to our REST APIs. They're not allowed to be connected to any other persistence layer. And at that, we have a proxy that sits in front of all of our services and kind of regulates rate limiting and authorization to different endpoints. So one app can only affect the rest of our infrastructure in a very limited way. And Memcache is the only service that it does directly talk to, and that's only to do CSRF validation. There's no sharing sessions between applications. If you need to do that, you have to build out an API endpoint and let somebody else take care of it. And then we kind of blessed a common asset bundle. So we're using jQuery, we use a specific version of Backbone and a specific version of Underscore, and we have our own base classes and stuff that people can inherit. And that just kind of comes to you out of the box. You don't really have a choice. With the whole idea that if you're on the deal page team and they want to spin up a new product, or if you're from another product team and you're moving to the deal page team, you shouldn't have to relearn how to Groupon or how to write a website. The toolkit should be pretty similar. And then we also just kind of wanted to take a step back and reevaluate how we would just do stuff over the wire. We had built out these really complex client-side rendered pages, mainly because our monolith was slow. But that was a bad reason to do that work. Groupon's kind of interaction model is you go to a page, you see a thing, you click buy, you enter your credit card number, and you're gone. Or you go to the page and bounce. So the more quickly we could render that page, the better. The less kind of browser bugs or things that we'd have to work around, the better. And then push all the business logic as far back into the API as possible. Like, this is just a presentation layer. You wouldn't expect your iOS app to do complicated business logic on the phone. Why would you expect your web layer to do the same thing? And then, since these apps are decoupled from the services, our backend should be able to go down, and we can at least do something other than a bad gateway or any other kind of standard error page. We should be able to cache some relevant data at that layer and just show something to our users. This is basically a quasi-pseudocode CoffeeScript controller from what you have, just to kind of emphasize, if I want to render a list of things, all I'm doing is fetching something from an API and sending it through our view layer, and then dumping that HTML out on the client. That's, at a high level, this is what every app at Groupon should be doing. So this is kind of where we decided to start with the subscription page. It was the first page that you see if you come to Groupon, where we harass you for your email address. That page was pretty useful for us because it was a simple application. We already had the APIs and stuff built out, and it was able to kind of prove the concept that we wanted. And moreover, it didn't look like the rest of the site. So we could just kind of hammer away at this page really quickly and launch something and get it out there and see if it worked. It took us quite a while to get this thing out. When you start a platform shift in your company, you're going to find a lot of assumptions about how your infrastructure works, and you're going to have to kind of like bump into them until you have resolved all of the blockers to launching something new. For example, like we didn't have we had a team that just did deployments. So we needed to figure out a safe deployment system that if we're going to democratize this and let 30 teams do their deployments, like we should make it easy for them. They shouldn't have to understand how everything works in our data center in order to get their app up. And then, other things when you move to a new platform is like you're going to hit some just growing pains with a new platform. We had problems with Rails. We knew how to solve problems with Rails, but we started running into problems with Node, and we had to kind of develop the operational knowledge of how to do Node at large scale. And I think anybody who's started with Node is going to run into the first problem immediately, which is for some reason they have this insane low limit of the outgoing HTTP connections that you can make from a Node process. So we would start running a load test, and like the app server looked fine. Everything was, all the metrics that we could gather looked like the web server was doing okay and handling the load, but the response times would just get longer and longer and longer. And it wasn't until I saw a tweet from Substack that said you should set, http://globalagent.max sockets to infinity on every project that you start. As soon as we kind of got past that, we were able to, we wanted to kind of stress test Node. So me and the director of QA kind of were like, all right, so we're going to take this JMeter script, we're going to hammer this thing at like a consistent amount of traffic over the weekend, see if there's memory leaks or whatever, but we'll do it on our test infrastructure, nothing should break. We started the test on Friday night, which is a bad idea, and then we're like, all right, see you later, have a good weekend. Within an hour, we got paged. So we found out that we didn't have we had a completely parallel set of databases and app servers and stuff, but we didn't have a parallel load balancer. And somebody put SSL termination on that for the test environment on that load balancer, so it spiked the CPU and took our entire website down. This is just stuff that we probably wouldn't have noticed in our old infrastructure, but now we're kind of like poking holes not just at our web, our web layer, but every other piece of our infrastructure all the way down. So we validated that this little subscribe page worked. We needed to move on to something more complex. So this was the second page. We called it like the browse page. It's just like a gallery of deals that you can find. And it let us solve like the next iteration of problems. Like people could have a logged in or logged out state, needed to make more than one service call, and a lot of that was dependent on the state of the browser. So what city you're in, or what kind of level your user's at. We had like the concept of a VIP user who could return Groupons all the time. All that stuff was information we needed to know now. And at the old subscription page was on one URL. Now we'd have to route a URL for each city that we supported to this application, and it took a lot more traffic. But the biggest challenge was the shared look and feel, which I'm going to get into in a minute. But this is kind of what our infrastructure looked like now. So we still have the Rails app, but we have this grout layer that diverts traffic to different applications, and then we also have this config layer, which I'll also explain in a minute. So we'll start with grout. This is the switchboard for our I-tier applications. For one or two applications, you don't need to build something like this out, but if you're rolling out 30 or 40 applications and you need to direct different URLs to different pages and map them to different upstreams, like having a good abstraction at this layer is super valuable. So with grout, we can route from domain, locale, country, and an experiment to a different application upstream. So for example, on this first URL, the routing layer knows that I'm in the US, I'm going to the deals page, I'm looking for the specific deal. So send this request to the VIP for my production deals page in our US data center. But when we're looking for the browse page in Groupon.de, it needs to be able to route that request to the browse VIP in our European data center and hit the right application. And the most powerful thing is that it'll let us integrate with our experiment framework so we could run experiments on URLs. So we didn't just cut over from our old platform to our new platform. we would roll out an application or a specific page at a small level of traffic. It would annotate every incoming request with that user. We could track that user's history through their entire browsing session. So we could actually validate that if you hit the subscribe page on the new iTier application, the new Node application, that your conversion rate, the whole flow, was the same as if you hit our old monolith, which really helped kind of, it was a good safety net to have, and it was a good kind of it was a good tool to use to explain to our business people that, hey, moving to Node isn't going to cost us money, it's not breaking the website, stuff like that. So here's, I don't know if you can really see this, but this is kind of like what the routing layer dashboard looks like. And we just have these definitions of different routes and what countries they're live in and how much they've been rolled out. And then this is like for a specific country, all the different pages that we can run an experiment on. So right now, this is a 2% experiment, one to the old, one to the new, and then we get annotations on both to see how it's faring. Gconfig is another thing that we had to solve. When you have a monolith, you can kind of cram everything into, YAML files in the Rails app. That wasn't going to work that well. We also needed to be able to turn things on and off on the fly, so we just created a simple Node application. All it does is, stores a blob of JSON and sends it down to the clients every couple of minutes. So that allowed us to decouple the configuration of our apps from the deployments, and we can have per host, per data center, and per app overrides for any one of these configuration settings. There's some problems with this piece of infrastructure. Like anybody who's worked on building distributed systems can probably name every single thing that went wrong with this application, but it was a naive start, and it's allowed us to at least get through this rollout. We'll probably be replacing it with something like etcd or something like that in the future. And then I think this is the most interesting part of the change is when you go from having one monolith, you can control the global look and feel from a centralized place. When you have 30 separate applications, you don't want them to all copy and paste that header and footer and common, like bootstrap or typographic overrides and stuff like that. That should be centralized somewhere. So we had kind of had a discussion about the way that we wanted to roll this out, and we've actually talked to companies that do variations of each one of these, but we decided to build a service. So we just created another Node app. It was basically like all the other apps that we built out. And all it does is when you make a request, it returns a partially rendered mustache template. So it has some logic itself that it renders out parts of that page. We'll send along the headers and the cookies and all that stuff from the incoming request. And then it will go make some service calls, like if you need to render a logged in user or something like that. It's taken care of at the layout service. And the actual nice part is that it'll send back the result of any service calls that it makes, so you don't have to make those service calls again. And it's also easy to use in development. A lot of those other tools would require you to have 2 apps up and running, or put an Nginx or something in front in order to do ESIs. This is just another service, and it returns all of its URLs to its own location, so you can just kind of spin it up and it'll just work in development mode just fine. Each version of the layout the layout itself is semantically versioned, so we can roll out patch or minor upgrades, and the consumers can subscribe to different levels of that version. So if you are our SEO team is very particular about the changes that we make, they might lock down to a specific patch and then do a lot of automated testing to make sure that it doesn't break. But for most sites, they can just lock to a minor and kind of roll forward with that. And it's awesome because this enabled us to do the site-wide experiments that we wanted. So this is an example of what the layout service returns. You can see it's just a template that kind of looks like Groupon, but with fill in the blanks of whatever you want to put in here. But with a query string switch, we can go from the old look and feel to the new look and feel. And it's basically the same thing. You just see that there's that unescaped body in the middle of that you can just put whatever content that you want. So we built out all these infrastructure pieces. We got a couple of pages launched. We're like, all right, let's do it. We're going to rewrite everything. And that's a tricky thing to do. Getting the whole company to move at once is very difficult. But supporting 2 platforms is hard, and we really need to just get it done. So we made this transition happen. We gave ourselves 3 months. We had 150 developers worldwide. They all just kind of dogpiled on this to get it done. And we also feature freeze, so we didn't change the website during this period of time. So what went well is that it worked. We are, in the US, we're completely off our old monolith right now. Our web pages got a lot faster, and we supported record traffic. So the 2 big spikes in here, one is Starbucks Day, which is like we sold like 1 million or so deals for Starbucks in a matter of like 8 hours or something like that. The last time we ran this deal, the whole site went down. And then the other 2 spikes towards the end are Black Friday and Cyber Monday. If you had ever followed like Aaron Hammer on Twitter, like we're kind of in the same boat as him. Like, yawn, nothing happened. We wanted to see some stress on our servers, but moving to Node really allowed us to have a good level of isolation from our backend services falling over. And I just like this visualization of like how our traffic is now distributed. So each one of these colors is a different application. So you can see that we're able to kind of scale or send traffic to applications depending on what they need. So the deal page and the checkout page need, get a lot more traffic. We allocate a lot more resources to them. But some pages are really small and barely get any traffic, and they just have a couple of tiny servers. There's some stuff that didn't go that well. Moving to an SOA is hard. There's a lot of overhead when you move to a distributed model. Testing gets a lot harder, especially end-to-end testing. And then there's some stuff that we need to build out, like distributed tracing, that isn't quite there yet. There's also culture problems. Like, we asked product teams to like really change their job description from I write code in this monolith, I commit it, somebody else has to deal with it, to you're completely responsible for the life cycle of your application. We just kind of threw that on people. I think if I had to do it again, we'd probably hold their hands a little bit more, or at least kind of work with them to find a model that made sense. The things that we're still building out, we're launching internationally. That has been rolling out slowly over the last month or so. So if you keep looking at groupon.de, at some point you'll see the new look and feel. That means you're on Node. Distributed tracing is something like we're trying to build a, this isn't just the front end, we're SOA for our entire architecture now, so we need a good way of being able to see what's going on. And then open sourcing this stuff. We've open sourced some modules that we built for ourselves, but we don't want to be one of those companies that kind of like throws something out on GitHub because it makes us feel good. We want to make sure that we're contributing stuff that's actually useful. So kind of changing our modules a little bit to make them more shareable. That's something we've been working on. So yeah, if you weren't paying attention, these are all the things that I just talked about. And thank you very much.